Good morning, my dear students. My dear Matheum 4/2 students. How are you today? So you are the group of the odd numbers, right? So again, just stay at home and I prepared here video for you so that you will be updated to what's happening here in the classroom. Okay, so just today we're going to start with the new topic wherein this is about the proper lesson about set. Okay, so we're finished already with the introduction to set and we're now in the operation and set. Okay, but before that, we're going to have a recap first to what we had studied last week. We have this one. So these are what we did about the equivalent set, superset, equivalent set, element, subset. So remember about this. Now for superset, these are the bigger compared to the smaller. Okay, and for the equivalent set, that is the we're talking about the elements. Okay, so the number of elements for each set, so it must be equal. It's not particular about the element content, but the number of elements or the cardinality. Okay, so we have here, this is the example of equivalent set. We're using two symbols for this. Okay, and for this one they are equal. This one is for superset. So you will see here, this one is a bigger set to this one. But if you're going to switch that, this one is a subset to this. Okay, so if this is a subset to this and you swap, then this one is a superset to this one. Okay, and we have here also the cardinality. For cardinality, if you remember, this is only you count the number of elements, right? You just only count the number of elements. So how many elements are there inside, then that will be then a cardinality. But for this one, you will only count this as once, like 1, 2, 3, 4, 5, 6. Okay, so you have there 6. So do not count this as 3 element, but only 1 element. Okay, this one is only 1 element, 1 element. And this one is 1 element, this one is another element. So even though that they are inside or enclosed in a brace, for this they are part of the elements. Okay, so we have here 2, and the last one you have 1, 2, and 3 elements. Also, this one is what we have done last week. This is activity that we have done last week. So remember again, for the subset, proper subset, equal set, equivalent set, superset, and we have here the power set. Now for the power set, if you still remember that this is the collection of the subset. So we are using this formula 2 power n so that we will know how many subset contains for that particular set. Okay, so we have here P for number 1 is equal to 1 and 2. P is equal to 2 power n is equal to 2 power 2 is equal to 4. Meaning to say that there are 4 subset for this set A. So again, remember that empty set is always included for the subset. Now remember that the definition of the empty set is a subset to any set. Okay, so you start with 1, then 2, then 1 and 2 combination. And don't forget to enclose the element into a brace like this. Okay, so it makes that a set. So for letter number 2, that is set B, we have 3 elements here, so therefore there are 8 subset. So we have here all the 8 subset. So you start with the empty set, then 1 by 1, then combination until such time you will arrive at equal. Okay, equal set. For this one, we have only 1 element. So you see, there's only 1 element. Okay, so we have 2, including the subset, the empty set rather. Now we go to our lesson for today, that is about the different operations, set operation. So we have here 4 different operations. We have the union of sets, intersection of sets, difference of sets, and the complement of sets. Okay, and first we're going to study first about the union of sets and the intersection of sets. Okay, so we have here the union of sets. Number 1, union of sets are the 2 sets combining 2 different sets. Okay, the symbol that we're using for union is like this, like a U, like this. So A union with B is equal to X is such that X is an element of A, or X is element of B. Okay, so just simply combine all the elements, but just only write the element once. If they are in common between the two sets, then write only that element one time. Just like this example, take a look. We have set A having 1, 2, 3, 5, 6 as the elements, B, 2, and 4. Okay, we just simply combine them, so we have 1, 2, 3, 4, 5, 6. So we just only write this common element as only one, like this. So therefore, the union of A to B is 1, 2, 3, 4, 5, 6. There's are the elements. Okay, now if we're going to draw this in an Euler diagram, it will look like this. So you see, you just only combine the two sets, combine together. Do you have any question? Okay, thank you very much. Now we continue. We have this example. Okay, so we have here the three sets A, B, and C. Okay, so all of these are in roster method. Okay, the notation for this. So again, we have here question number 1, A union with B. So we have there one with these two sets, 1, 2, 3, 5. Okay, it's easy. For C, for the second one, C union with A. So 1, 2, 3, 5, 6. Okay, so just combine. You see, we did not write twice the 3, which is in common. Just only write once. B union with C, we have 1, 2, 3, 5, 6. Yes, from here. And A to C is the same as this. Okay, it's very easy for the union. So we have another one. So this is what? What kind of notation is this? If you still remember, this is the set boulder notation. Okay, wherein that for this is kind of a set presentation wherein you only write the description of the set. So we have here for set A, x is such that x is an element of the natural numbers wherein x is lesser than 5. So what are the elements? So remember that the natural numbers start with 1, 2, 3, 4, 5, etc. But this is only lesser than 5. So we have how much? 1, 2, 3, 4 only. Now for set B, we have x is such that element of the positive even integer wherein that x plus 2 is lesser than 8. So we're going to find this one first, x plus 2. So for the positive even, we have 2, 4, 6, 8, 10, etc. So we choose only which is can give you lesser than 8, which is 2 and 4. And we have the C here. So we have the question, A union with B, A union with B, we have 1, 2, 3, 4. C union with A, 2, we have the 2, 4, 7, 8. So 1, 2, 3, 4, 7, 8. Okay. B union with C, we have 2, 4, 7, 8. Okay. Or C. B union with A, we have 1, 2, 3, 4. It's easy. Just combine the elements, the two sets, just only write once if that elements are common. Okay. Now we go to the second one, which is the intersection rather. Intersection. Intersection of two sets A and B are their common elements. So we are talking about the common elements between the two different sets. Now the symbol that we're using is the inverted union. This one. This is the symbol that we use for intersection. So A intersect B is equal to x such that x is an element of A and x is an element of B. So meaning only the common elements between the two sets that we are to be considered. Just like this example. Set A is equal to 1, 2, 3, 4 and set B we have 2, 3. So what are the elements which are in common? They are 2 and 3. Okay, so therefore A intersect B is 2 and 3. Okay, and by the use of the Venn Euler diagram, so this is part wherein that they join together as their intersection. Okay, so not all part of A and B are joined together. Just only the common element between the two sets. Okay, did you understand about intersection? Thank you very much. So we have here more example for intersection. We have here the set A, set B, and set C. Okay, so again, we have A intersect B. So A intersect B, what are the common? We have 3, we have 6. Okay, so we have 3 and 6. 3 and 6. So we have 3 and 6 here. Again, for this one, we can swap. B intersect A or A intersect B, they're just the same. C intersect A, we have this and this. So we have 1, 3, 4 and 1, 3, 4. This one. Okay, 1, 3, 4. We have 1, 3, 4. B union with C, we have 3 only. This one, 3. No 1, no 4, only 3. Okay, we have 3 here. A intersect with C, we have 1, 3, 4. Okay, 1, 3, 4. Just like this. We just get the other way. Okay. Now the second example we have, so we have here again the set builder notation, but the elements for this, it says that set A is equal to x such that x is greater than 2 but lesser than 4. So we have what? 3, 4, 5. Okay, we have there. So we have here the set A, set B, and set C. The questions. A intersect B. A intersect B. So we have only 3 and 3 in common. We have here 3. A intersect C. A intersect C. So you have only 5 and 5. You have 5. Okay. B intersect C. B intersect C. No. No common member. So that's why we answered that as empty set. So remember that we have two symbols for empty set. The one is like this, and the other one is like a circle, like O with a bar, okay, a crossing bar. So that is the for this B intersect with C. B intersect with A, we have, so the same we have here, this one already, intersect B, so we can swap. Okay, so question, do you have any question about the intersection of set and the union of set? So again, remember, for the union, just simply combine all the elements. Combination. So if there would be like common elements, just only write that one only one time. Do not repeat the number again. If like 2 and 2, you will not say 2, 2. No, just only one time, 2. Okay? So for intersection also, you will just choose only with the common elements. You will check one by one the elements of two sets, then whichever is in common, then it will be the intersection between the two sets. Okay, so again, if you don't have any more question, we're going to continue more about this, like number 3, the difference, and the number 4, the complement, okay, of any set. So again, if you have any question, you can comment below, or you can ask me in my line or in my Facebook if you want to add me. And that's it. So again, hopefully you will understand and try to practice. You can read your book, okay? So that, or you can, watch my video again and again so that you will understand more about this. So again, that's all, and see you again next week. Bye bye.